This video, we're going to go through Calculus 1 midterm exam. In particular, we will provide the solutions of 3 essay questions. The first problem, we have to find the tangent line to the curve tan of xy equals to xy to the power 3 plus 2y to the power 2 minus 8 at the point 0, 2. For solving this problem, explanatory comments are provided using green color. I'm not going to go through the green color reading, so that's just for further details. But what we have to do is to find the tangent line, and to do that we have to do the derivative first and then evaluate the derivative at this point to find the slope, and then we will find the equation of the tangent. Now dy by dx of this is the curve equation. The only difference is that we moved the right hand side to the left hand side, and that's why we have in blue the modified curve equation equal to 0. And this implies if we execute dy by dx for each term, we get sec square of xy, and in purple is the derivative of the inside. Of course, derivative of tan is sec square, and that's why this is the derivative of the outside and this is the derivative of the inside. The second term, we have x y cubed, the derivative of the second term. First derivative with respect to x will give us minus y cubed, and then derivative with respect to y will give us x 3y square dy by dx. Once again, the ones in purple involve implicit differentiation. Minus, and we have the derivative of 2y square will be 4y dy by dx, plus derivative of 8, that's going to be equal to 0. And all of this is going to be equal to 0. Now it's very clear that we have to take the terms with dy by dx on one side, and then we have to solve for dy by dx. So let's go for it now. We colored in brown the terms that do not involve dy by dx. So there are only two terms, y sec square of xy and minus y cube. We'll keep them on one side. The rest will go to the other side, and then we solve for dy by dx, and this is the result that we're going to get. Dy by dx will be equal to y sec square of xy minus y cube divided by the equation on the bottom. These are all the terms that involve dy by dx. So from here, the next step is we have to plug in 0 for every x and 2 for every y, and we will get at the point 0, 2 the derivative dy by dx equals to 2 for the y and sec square of, since x equal to 0, sec square of 0 will be equal to 1 minus y cube, and y is equal to 2, so it's minus 8 divided by the bottom. Every time we have a term with an x, that is 0, so this first term is 0 plus the second term is 0. The third term is 4 multiplied by 2, which is going to give us 8. So at the end, the derivative evaluated as 0 and 2 is going to give us negative 3 divided by 4, and that is the slope. And then from the slope, we could go ahead and generate the equation using the general formula for linear functions, y equal to mx plus b. If you plug in for y2 and you plug in for x0, it will be clear that y, which is equal to 2, is equal to b. And then we could just go ahead and plug in for the equation negative 3 divided by 4 multiplied by 0, which is the value of x, plus b. This proves that b is equal to 2. And from there, the equation will be negative 3 divided by 4 of x plus 2. That's it for this one. Let's move on to the next question. We have to evaluate the following limit. Limit as t goes to 0 of the function square root of 1 minus t square minus square root of 1 plus t square divided by t square. Obviously, this is the comment, so we're going to go ahead and multiply denominator and numerator with the conjugation of the numerator. And to do that, this is what we're going to get. Limit as t goes to 0 of 1 minus t square minus 1 minus t square divided by t square multiplied by the conjugate. And if we rearrange, we can see that 1 cancels with 1, and we will end up with negative 2t square divided by t square multiplied by the conjugate. If we plug in t for every occurrence of t on this right hand side, this is what we're going to get. We're going to get negative 2 in the top. Why? Because t square cancels with t square. So since t square cancels with t square, numerator will be left with only negative 2, and denominator will be left with this square root of 1 minus 0 plus square root of 1 minus 0, which will give us 2. So negative 2 divided by 2 is equal to negative 1. And that is the answer for this question. Let's move on to the next question. Next, we have to find the value of g of x. We're given the function f of x equals to 2 divided by x plus 1. And the composite function f circle g of x equals to 2x divided by x plus 3. We're asked to find g of x. Before we go anywhere, our next step is to rewrite the composite function. So the composite function f circle g of x equals to f operating on g of x. We know if f operating on anything, then right hand side will be 2 divided by that thing plus 1. That means this is the parameter f operates on, and it will go to the denominator as the first term. And g of x is the parameter x is operating on, so g of x will go in the denominator just like over there. So this will give us f circle g of x, the composite function, is equal to 2 divided by g of x plus 1. But also the composite function is equal to 2x divided by x plus 3. So we can see it's right here. Now only thing that we have to do is solve for g of x. To do that, we can say that 2 divided by g of x plus 1 equal to 2x divided by x plus 3. It implies, if we cross multiply, it implies that 2x g of x plus 2x equals to 2x plus 6. Dividing this equation by 2, we get x g of x plus x equal to x plus 3. Obviously, we can just cancel x from each side, and we'll end up with x g of x plus x equal to x plus 3. From it, we can deduce that g of x is equal to 3 divided by x. Why? Because if we cancel x with x, we'll have x g of x equal to 3. So g of x is equal to 3 divided by x. And that's the answer, and that's it for this part of the midterm, and good luck.